In the last video, we looked at how to use the concept of the expected value to compare different alternatives. All right. In this video, we're going to look at another thing that we're going to use to compare alternatives. But before that, let's just look at what we've got up here, and I'm just going to talk for a while so that you have a chance to copy this down. All right, we're going to be erasing it here shortly, so make sure you get that down. All right, but before I erase it, let's just kind of run through what this is. All right, so let's say that you are working for a company, all right, and you have been presented with two different marketing campaigns, and somehow they are, somehow people created these probability distributions for them. We're going to assume that they're discrete probability, they're discrete random variables, right? And our discrete random variable x is the profit that you get from this marketing campaign, all right? Again, not really realistic that these would be kind of discrete probability distributions or that they would have these values, but just for simplicity's sake, we're going to make those assumptions. All right, so we've got option A. We see here we've got our different outcomes and our probabilities, and we see that we have an expected value. All right, so the expected value for the profit for option A is $675. All right, for option B, again, we have our outcomes, we have our probabilities, and we can see that our expected value, or the expected value for the profit, is $1,400 for option B. Right, so if we were just going based off of expected value alone, right, which one would we end up choosing? If we're just going off of expected value, we're probably going to pick option B because it has the higher expected value, right? Telling us that over multiple iterations, let's say this is kind of monthly profit, right? As month after month as we run this campaign, right, our average profits are going to move towards $1,400, right, for option B, whereas for option A it's only $675. All right, so again, if we're just looking at our expected value, we're probably going to choose option B. All right, but that's not necessarily the only thing that we might be concerned with, right? We might not just want to see which one's going to give us the highest profit. All right. We might also want an idea of how consistent those profits are. Right. Maybe we just don't want to have profits that swing wildly month to month. Maybe we don't have the reserve capital to take that kind of risk. Right. Whatever it is. Right. We might want to get an idea of consistency. All right. How consistent is this going to be? All right, so hopefully everybody's got this down. If you don't, you might want to pause the video and finish kind of writing everything down because we're going to be using this information, but just because it takes too long for me to write it all out every single time, we won't be throwing these back up here, all right? So when we are trying to figure out kind of consistency, right, how consistent our profits are going to be, what we are going to look at is the variance. All right, so the variance of a discrete random variable is given by the following formula. All right, so the variance is equal to the sum of xi minus the expected value of x squared times the probability of xi. I'm going to move that down because I got a little scrunched at the end there and I don't want it to be scrunched. All right, so the sum again, the sum of xi minus the expected value of x squared times the probability of xi. All right, so this formula usually looks a little daunting to students. All right, it's really not. It looks. I will admit it looks bad, but it's really not that bad. All right, essentially all we're really doing is the exact same kind of stuff that we would do for the variance of just a random variable x, like we did in chapter 4. It's not that different. Just like with those variances, it's just kind of a lot of. It's kind of a little time consuming, right? But here we've got our xi minus the expected value, right? Squared, that's really just the squared deviation from the mean, right? So remember that the expected value of x is the mean, right? And then this probability, this is essentially, what this does is it replaces whatever we're dividing by, all right? But again, kind of we're gonna do one of these terms for each kind of pair of outcome and probability. All right, so let's go ahead and actually look at this in an example. All right, so we're going to start with option A. All right, we're going to find the variance for option A. All right, so again, this is essentially, it's really not that bad. It just takes up a lot of room to write it all down, but let's go ahead. All right, so the first thing we're going to do is we're going to take our first possible outcome, which was negative 1,500 for option A. We're going to subtract our expected value, which was 675, and then we're going to multiply that by the probability of negative 1,500. All right, and then we're just going to do this for the other 4 possible outcomes. All right, so 0 minus 675 squared times 0.1, 500 minus 675 squared times 0.4 plus 2,000 minus 675 squared times 0.2, and finally 3,750 minus 675 squared times 0.1. All right, so if we can, again, this is going to depend on which calculator you have. You can put this all in at once. If you are going to do that, definitely make sure that you've got brackets kind of in the places where they need to be. Right? Know your calculator, because if you mess up kind of placing those brackets, you're going to mess up the order of operations and you're going to get the wrong answer. Right? You don't want that happening. All right, so be careful of this. Right? Might be easier, right, to just do these kind of one at a time. But regardless of how you do it, once you get those values, all right, you add them all up, you're going to find a variance of, let's see, 2,300,625. Right, and that is how we're going to do that variance calculation. Now, when we look at our final answer, right, 2,300,625, right, that doesn't necessarily tell us a whole lot. Luckily for us, just like with the variance stuff we looked at in chapter 4, we can also find the standard deviation. And once again, the standard deviation is just the square root of the variance. All right, so for option A, if we wanted to find the standard deviation, right, that would simply be the square root of 2,300,625. All right, and when we put that into our calculator, we're going to get 1,516.78. All right, so again, kind of our standard deviation, essentially what we're saying with that is that's kind of the common amount we would expect. It can kind of help us get a range for where we're actually going to fall, right? And kind of, again, standard deviation, how far away from the mean are you likely to be, right? And so here we've got 1,000. And this is back in the original unit, so $1,516.78. That would be our standard deviation. All right. Now, by themselves, these numbers might not necessarily be very helpful, right? And so what we need to do is find the same values for option B. All right. So for option B, when we are looking at our variance, we're going to do the exact same steps. All right, we're going to take each of our possible outcomes. We're going to subtract our expected value. We're going to square it, and then we're going to multiply by the probability of that value. All right, that outcome. All right, so again, really just kind of setting it up takes a little while. If we can put it all in at once, that's fine. If not, then we might want to, or if we're having trouble or if we're getting the wrong answer, we might want to just do each of these little terms one at a time, right, to help us kind of avoid any mistakes that we're making. All right, but once we get it in there, I'm going to go ahead and erase this and just put our variance up here. All right, so once we've plugged that into our calculator, right, we should get a variance of 6,640,000. All right, and of course, if we want to find our standard deviation, then that is simply the square root of 6,640,000, which is going to give us 2,576.82. All right, so once we've got all of that, we might want to kind of consolidate some of this information. All right, so we're going to just go ahead and write down kind of the key results from option A and option B. All right, so for option A, our expected value was 675. Our variance was 2,300,625 with a standard deviation of 1,516.78. For option B, we have an expected value of 1,400, a variance of 6,640,000, and a variance of 2,576.82. All right, so we've essentially spent most of this video kind of going over the math part of it, actually getting to the answer. So let's talk a little bit about what these answers mean. All right, so we kind of already know, all right, about the expected values. Right, the higher the expected value, in this case, right, specifically in this case where we're looking at profit, right, the higher the expected value, right, the higher the profit is over kind of multiple iterations, right? So if we kind of pick option A, right, kind of, and go month after month running this marketing campaign, right, and then we took the average of our results, right, that's going to move towards that 675, right, especially as we continue to iterate that experiment, right, as we continue to go month after month, right, running this marketing campaign. Right, same is true for option B, except for that value that it's going to be going towards is $1,400. All right, so if you are wanting to just have the highest profit, right, and you are choosing between option A and option B, right, then you would choose option B. All right, then looking at the variances, and really probably the easier thing to do is to look at the standard deviations, because it puts it into a little bit more understandable format, in my opinion. Right, so that's what we're going to look at. One, you can look at the variances and say, well, you know, this has a much lower variance. Option A has a much lower variance than option B. Right, if we have a lower variance, right, and this is true for standard deviation as well, right, kind of the higher the variance, the higher the standard deviation, right, the more volatile whatever we're looking at is, right, the more we're going to see larger swings, kind of larger movements around the mean, right, and so you're going to have less consistent profits, right, with a higher standard deviation, right, and so here we can see, right, the standard deviation for option A, right, $1,516.78, right, so that's saying that we could, you know, we're going to oscillate, right, or likely oscillate around this number, right, and most of the time either be, you know, about $1,500 below 675, so negative $900, or about $1,500 above, so around $2,100, right, in our profits. All right, so that's what it's telling us. All right, with option B, we have 2,576.82, right, and so there's more movement, right, or a kind of the magnitude of that movement is higher. All right, so if you were a little bit more conservative, more risk averse, didn't want to take on the risk of losing kind of more money, right, then you might choose option A, all right, or whatever it is that has the lower variance, lower standard deviation, right, because that's what's telling us about that consistency, right. It's a measure of variance, measure of dispersion, telling us how spread out our data is, right. If we were looking at something like profit, we might want kind of a tighter grouping around the mean, right, but again, that's going to be determined by how risk averse you are, right? Do you want to, you know, risk it all to get a big prize, or do you want to just take the lower risk option and kind of get a lower but maybe more consistent profit? All right, so if I ever asked you, kind of gave you a problem where I gave you two probability distributions, and then I asked you to compare them on the kind of basis of expected value and variance, or standard deviation is probably what I would say, right? I would want you to find those four pieces of information, and then I would want you to kind of compare and contrast, right? Say option A has a lower expected profit, but it has a lower standard deviation as well, right? Which is going to indicate that it's a little bit more consistent, right? And then kind of a similar thing for option B. If I ask you which one would you pick, which one would you suggest, anything along those lines, right? What I'm looking there for there is just really you can pick either one, right? You could pick option A or option B and be correct on a problem like that, right? If I'm asking you which one you pick, but the big thing is I want you to explain why you chose the one you chose, right? And that's where that's what's going to determine whether you get the answer right or wrong, right? If you say, I choose option B because I want higher profits, right, and the expected value is higher, right, that's a perfectly valid answer. Right, if you say I want option A because it has a lower standard deviation, right, and that's going to give me more consistent profits, right, that's also a valid answer. Right. If you say I want option B because it has a lower variance and it's more consistent, then that's when you would be wrong. All right. So you can pick either one. You just got to have the right justification for choosing the one that you do. All right. But that is it for our video on really variance, essentially just the variance. But very important. All right. Kind of a long, time-consuming process, but right, it is important. And later on, we'll get to some things where there are some kind of situations where you don't have to do those big long calculations. All right, but that is it for this. So kind of everything up to this point has just been for any discrete random variable, right? Any discrete probability distribution. So this applies to kind of anything that falls in that realm, including what we're about to cover, right? But what we're about to cover, we're going to look at some specific types of distributions, right? And what we learn there is only going to apply to those specific types of distributions. All right. Again, everything that we've learned so far applies to what we're going to cover next, right? But some of the stuff we cover next is going to not apply to everything, right? Okay, so yeah, we are going to be, in the next couple of videos, we're going to be looking at two specific types of distributions. We're going to look at the binomial distribution first, and then we will be looking at the Poisson distribution, right? But that's it for this video, and I'll see you in the next one.